Hey guys, this looks like a lot of fun. In this multiplication sum, W represents the same digit every time. What is the value of W? If you want to have a go, pause me here, because I'll start solving in 3, 2, 1. First, let's take stock of all the possible values of W. W is a digit, so we can take all the possible values from 0 to 9. Let's push both the question and our possible values into the corner and get to work. What we could do now is substitute every value from 0 to 9 in for W. This brute force approach will get us the answer eventually, but it'll take quite a long time, especially given the large multiplications involved. What we could do instead is play a much cleverer elimination game, deleting values from our list that we know for sure can't be W. To do this, we need to spot interesting things with our multiplication question. First off the bat is the column of W's in both the question and the answer W's. This means that W multiplied by W must give W in the units column. And what we can do is try each value from 0 to 9 in this unit multiplication, which we can do quite fast, to eliminate a lot of the values from 0 to 9. First, 0 times 0 gives 0 in the units column, so this is still a possible contender for W. Likewise, 1 times 1 is 1, so 1 will appear in the units column, which fits the bill for W. However, 2 times 2 is 4, and 4 is not 2, so we can eliminate 2 from our possible values of W. 3 times 3 is 9, and as they don't match, 3 can also be eliminated. 4 times 4 is 16, and we don't need to worry about the 1, we're just interested in the unit. 6 is not equal to 4, so 4 is also eliminated. Moving on to 5, 5 times 5 is 25, and since 5 appears in the units, 5 is a possible contender. Let's move on to 6. 6 times 6 is 36, and 6 is in the units column, so 6 is also a possible contender. Moving on to 7, 7 times 7 is 49. As 9 is not equal to 7, 7 is not a possible contender for W. Likewise, 8 times 8 is 64, so cross this out, and 9 times 9 is 81, so cross that one out as well. What we've done now is shortlisted our possible values for W to just 4, 0, 1, 5 and 6. At this stage, we could also substitute our values for W directly and work them out. It would be shorter, but we can do some more elimination. At this stage, to spot something more interesting, we can take a look at the boundary values. Let's take a look at the least possible value of our multiplication. Well, the least possible value of W is 0, so subbing this in to our question equation would be 30 multiplied by 400. We've popped in zeros where the W's are in our question. This gives an answer of 12,000. 12,000 is the minimum possible answer value that our answer could take. So that means 1W 92W must be at least equal to or greater than 12,000. For this to happen, the key value we can spot by inspection is W over here. This W must be 2 or greater for this to happen. So that means 0 and 1 can be kicked out of our possible values of W. What we're left with is just 5 and 6. At this stage, we can directly sub in W equals to 5 and W equals to 6 and see if either one, or indeed both, fits the bill. When we replace W with 5, we get 35 times 455. Performing this by hand or using a calculator, we get the answer 15,925. Comparing this to the answer that we want, all our 1, 9 and 2 are in the right place, and our W's are in the right place as well. So 5 is a possible answer. We need to also check if 6 is an answer as well, so 36 multiplied by 466 gives 16776. Now while our 6's are in the right place, 9 and 2 don't appear in this answer, so 6 is not a value for W. Our final answer, therefore, and our only answer is 5. w equals to 5. Thanks for watching Beat the Calculator. See you next time for more logic and maths fun.